Okay, so this is the 10-7 notes. This is solving for inverse equations. This is using methods that are very similar to our 8.3 notes, where we were writing inverse functions by swapping x's and y's. The same property is going to hold here. So first, we're going to calculate the inverse function of these examples, and then we'll talk through domain and range. So first, when we're doing inverse functions, when we're calculating those inverse functions, we rewrite it as y equals, replacing f of x. Then to do the actual property of an inverse, wherever I see a y, I swap it with an x. Wherever I see an x, I swap it with a y. And I copy down the rest of the equation exactly as was. Now the last goal here is to resolve for x. Or I'm sorry, to solve for y here. I'm going to highlight that, what we want. So first I'm going to get rid of that -5 by adding 5 on each side. Then I'm going to divide away the 2 to start to isolate that exponential function. And now that I have this exponential function isolated, I'm able to get rid of an exponential function with what we now know as the inverse operation by taking the natural log of each side. Now notice when I take the natural log of that right-hand side, this exponent is going to pop out front, right? That's one of the powers of a logarithmic function, is that exponents inside of a logarithm are coefficients out front of a logarithm. So this is now 3y times the natural log of e. And notice the natural log of e is 1. So this is 3y times 1, which is just 3y. So I'm going to rewrite this equation up here that we have the natural log of x plus 5 over 2 is equal to 3y. My last step is going to get rid of that 3 being multiplied by dividing it away. Thus, we have the natural log of x plus 5 all over 2, all divided by 3 equals y. Thus, my inverse function, the last step for me to take is to replace that y with my inverse notation, f inverse of x. Now let's talk about the domain of f, the range of f, I'm going to put it up here, the domain of f inverse and the range of f inverse. Okay, so let's go ahead and let's start with the domain of f. F is an exponential function. Its domain is all real numbers. Just like f inverse is a logarithmic function, its range is all real numbers. And we know that inverse functions have this property where the domain and range swap with one another. Now to determine the range of f or the domain of f inverse, notice for a function like 2e to the 3x, the range would be from 0 to infinity. But we have that -5 that shifts this this interval down 5. Thus, the range is going to be from -5 to infinity. And that means the domain of f, notice we did move it left 5 here, is going to be -5 to infinity. From its normal domain of 0 to infinity, it was moved left 5. Notice it's not moved left 5 halves because I have to factor out that 1/2 horizontal stretch factor from the x and that horizontal translation. So just to finish here, I'm going to highlight those finals, domains, and ranges. All right, next we're going to calculate the inverse of this function here. Again, I'm going to start the same exact way, start replacing f of x with y, and I copy down the entire equation. Now to do the inverse, I swap x's and y's, and I recopy down the rest of the equation. And then to rewrite this as f inverse, I need to isolate the y. So first I'm going to add 9 and then divide by 5 to get this exponential isolated. That's always the first step, is to try to isolate that exponential. So I have x plus 9 divided by 5 is equal to 2 raised to the 3y minus 1. Now that I have it written where the exponential is isolated, I can get rid of that exponential function here because we're not needing to use our calculators at all. We can get rid of 2 to a power by using log base 2. I typically only recommend using like natural log or log base 10 when you're going to need to eventually use this in a calculator. But technically that could still work. You're just going to add one more step in for yourself. All right, so log base 2 of 2 to a power, those are inverse functions. They cancel out with one another. That equals 1. And we're going to see that power, the 3y minus 1, pop out front. And again, we can write that that's multiplied by log base 2 of 2, which is really just that 1. And that equals log base 2 of x plus 9 over 5. So I have 3y minus 1 times 1, that's just 3y minus 1, equals log base 2 of x plus 9 over 5. I'm going to add 1 to the left-hand side and then divide by 3. So we get that log base 2 of x plus 9 over 5 plus 1. Notice that plus 1 is not inside of the logarithm. At this point, we already took the logarithm, so that's closed. All divided by 3 equals y. And I'm just going to rewrite that y as f inverse of x for that notation. Now let's go through the domain of f, the range of f, the domain of f inverse, and the range of f inverse. F is an exponential function. We know its domain is all real numbers, just like the range of f inverse, that logarithm is all real numbers. Next, talking about the range of f. Typically, when we see an exponential, it goes from 0 to infinity. It doesn't reflect that 5 out front is not negative. So that doesn't do anything. The horizontal stretch compression, shifting left and right does nothing as well to that range. But moving down 9 does affect this. So I'm going to subtract 9 from this. So I'm going to show that. And I get from -9 to infinity as that range. Thus, the domain of f inverse is also -9 to infinity. Notice again, we do have that moving left 9 factor inside of the logarithm. So here again, we have that final domain and range of f and f inverse. Next, we're going to calculate the inverse of this function. Notice this is a logarithmic function with a base of 10. Again, I'm going to start like normal, replace f of x with y. I'm going to first subtract the 7 and then divide away the 6 because my goal is to isolate the logarithm before I can get rid of it. So I have y minus 7 divided by 6 is equal to log of x minus 1. Now that I have that logarithm isolated, I can get rid of it using an inverse function. Log base 10 is the inverse of 10 to a power. So I'm going to raise each side 10 to that power. So now I have 10 to the y minus 7 over 6. Oops, sorry guys, I have my x's and y's swapped over. I never did that inverse property. Let me shift this down really quick. Here we go. I need to swap x's and y's here. So I have 6 times log of y minus 1 plus 7. Now I'm trying to isolate this y value. Let me get rid of that. Here we go. I have 10 raised to the x minus 7 all over 6 equals 10 to the log base 10 of y minus 1. Now that I have 10 raised to the log base 10 of something, those are inverse functions and they cancel out, leaving me with 10 to the x minus 7 all over 6 equals y minus 1. Last step, I'm going to add 1 over. Notice that adding 1 would not be in the exponent. So we're left with 10 to the x minus 7 over 6 plus 1 is equal to y, which is equal to the inverse function of f. Talking through domain and range of f, as well as the domain of f inverse and the range of f inverse. I would start with f. I know all real numbers goes with the range. A logarithm has range of all real numbers. If I looked at f inverse, I know its domain is all real numbers because the domain of an exponential is all real numbers. So those are the easy ones to find this time. Now to find the domain of f, we take that x minus 1 and I say it has to be greater than 0. What's inside the logarithm has to be positive. So x has to be larger than 1. That means my domain as an interval is from 1 to infinity. That means I also have the range of f inverse as from 1 to infinity. Notice it really did move up 1 from 10 to the x power in terms of vertical transformations. So the normal range from 0 to infinity really did move up 1 to go from 1 to infinity. Next, we're going to calculate the inverse function here. So I start by replacing f with y, and I copy down the rest of the function. Next, I swap the x and the y. And my goal is to resolve for y. I'm first going to get rid of that plus 9 and that multiplying by 8 because my goal is to get a logarithm isolated before I continue. So I get x minus 9 over 8 is equal to log base 7 of 3y minus 1. Now that I have my logarithm isolated, my goal is to get rid of log base 7 of something by raising each side to the 7th power. And that's again because 7 raised to the log base 7 power of something are inverse functions. Thus they cancel out and I'm left with 7 to the x minus 9 over 8 is equal to 3y minus 1. I'm going to solve for y normally by adding 1 to each side and then dividing everything by 3. So we end up getting 7 to the x minus 9 over 8 plus 1, all divided by 3 equals y, and that is f inverse of x. Going through the domain of f, the range of f, the domain of f inverse, and the range of f inverse. First for f, its range is the really easy one. It's from negative infinity to positive infinity. Again, that's because a logarithm, the parent function looks something like this. The y values is all real numbers. So I also know the domain of f inverse, the domain of an exponential we know is all real numbers. Then for the domain of f, we can take that 3x minus 1 inside of the logarithm and say that it has to be positive. I can't have a negative number in there. So I get 3x is greater than 1. That means x is greater than a third. So as an interval, I would write that as a third comma infinity. Thus, we also have the range of f inverse as a third comma infinity. Notice with f inverse, we really did move up 1/3. So that traditional 0 to infinity got shifted up 1/3 to 1/3 comma infinity. Last example here, calculate the inverse function. What I'm going to do is I'm going to combine these into a single logarithm. That way I can use e to a power to get rid of them because remember those are both log base e's. So this is really y equals, and then I notice I have subtraction between logarithms. That's division inside of a logarithm. So this is x minus 1 divided by 4x minus 7. Now I'm going to swap the x's and y's, so I get x equals the natural log of y minus 1 over 4y minus 7. Now that I have it rewritten as a single logarithm of something, I can use the inverse of a natural log of a log base e by raising each side e to that power. So when I solve this, now I have e to the x equals, on the right-hand side, e to the natural log of something are inverses. They cancel each other out. So I have y minus 1 over 4y minus 7. Now I'm going to multiply each side by that 4y minus 7. So I have e to the x times 4y minus 7 is equal to y minus 1. Remember, my goal here is to isolate the y, so I want to try to eventually moving all the y's to the same side of the equation. In order to do that, I need to first distribute that e to the x to every single term. So I have 4 times e to the x times y minus 7 e to the x equals y minus 1. Now I'm going to move all the y's to the same side of the equation. I'm going to choose to move it over to the left-hand side. So I have 4e to the x y minus y equals, I'm going to move that negative 7e to the x to the other side because it doesn't involve a y. 7e to the x, and I still have that minus 1. Now that I have all the y's combined to this left-hand side of the equation, I can factor out a y from each of those terms. And when I do that, I'm left with 4e to the x minus 1 being multiplied by that y. Now that y is being multiplied by that, I divide each side by the 4e to the x minus 1, and we get y is 7e to the x minus 1 over 4e to the x minus 1, and that is in fact f inverse of x. Now talking about their domains and ranges, the domain of f, the range of f, the domain of f inverse, the range of f inverse. Start with the easy ones, the range of f and the domain of f inverse. Let's start with the domain of f inverse. F inverse here, it looks like an exponential function, but I do have division going on, so I have to make sure that the denominator is never 0. So I'm going to check, can 4e to the x minus 1 ever equal 0? Do I have to restrict any values? So I get 4 times e to the x equals 1. E to the x is 1/4. I get rid of e to the x by taking the natural log of each side. So x is the natural log of 1/4. Okay, that is a value I have to consider. So this is all real numbers except for that value. So I'm going to go from -infinity to the natural log of 1/4 union the natural log of 1/4 to infinity. And that means that that's also my range of f. So I'm going to copy and paste that over here as well. Now let's talk about the domain of f here. Now I'm going to look at f like it originally gave me up here as the natural log of x minus 1 minus the natural log of 4x minus 7. That's my original f equation. For domain, I know that what's inside of the logarithm has to be positive, so I can set each one of these insides as greater than 0. So x is greater than 1 and x is greater than 7/4. Now I need both of these to be true at the same time. 7/4 is 1.75. So between x being greater than 1 and greater than 1.75, it must be greater than 1.75. And if it is, it matches both those inequalities, right? 2 is greater than 1 and it's greater than 1.75. But like 1.5 is greater than 1, but it's not greater than 1.75. So it has to meet that higher threshold. So we're going to stick with the domain that x has to be greater than 7/4 here. That means the domain of f is from 7/4 to positive infinity. And that's also the range of f inverse from 7/4 to positive infinity. And looking at f inverse of x, that would be a little bit tougher to see. I would definitely recommend going through and finding that domain and range in red here by looking at the original function f and determining its domain. You have a much better shot of getting that one right. All right, that's the end of these notes in our red folder. I hope you guys have a great day. Bye.